Hello. In this video, we will try to find out the area and centroid of some popular shapes. Okay, and we will try to just find out the pattern lying in between. Okay, so let's see. If we have a straight line joining from here to here, consider this as our origin. In every case, we will consider our origin as this point. Now, if the curve joining these 2 points is like y equals to x to the power 1, which is linear, then the area of this shape can be written as 1 by 2 into b into h, where b is this width and h is the ordinate or height. If the curve becomes y equals to x square or a quadratic one, then the area becomes 1 by 3. For cubic curve, it is 1 by 4. And in general, for any curve which is of form y equals to x to the power n, this is in general 1 by n plus 1 into b into h. Now, what is this b into h? This b into h is nothing but, if you just form a rectangle with this b and h, with this width and the height, then this rectangle, the area of the rectangle is b into h. Now, if you just cut it with a straight line or a linear curve, then you will find that just half of the area you are getting. Now, if you just take this curve little down, or if you use this as x square, then your area becomes 1/3 of base. That means almost 33.33% of the total area. Total area is BH. Okay, so this is how it works for area. We can surely see the pattern. The next part is the centroidal distance from the right end. Okay, from the right end, mind it, from the right end where our centroid lies. This centroidal distance we are looking for. Now, here also we know that for x to the power 1, it becomes 1/3 of this width. For x square x to the power 2, it becomes 1 by 4 into b. For cubic, it becomes 1 by 5, and in general, it becomes n plus 2. Now, we can see, surely visualize the pattern. Okay. But the question arises, why it is so? Okay, why we are getting in such a pattern that every time the area is coming as n plus 1 by n plus 1 into the whole area, and the centroidal distance from the right, okay, where our ordinate lies, main ordinate, that becomes something 1 by n plus 2 into the width. Here lies the question. Okay, let's try to just answer it. See, to find out area, we just need to calculate by integration. We just have to have our integration, as simple as that. Okay, initially I told that we are considering our origin here. Okay, so this is our x-axis, this is our y-axis, this is our origin. So at x equals to b, y value is of course h. So at x equals to b, y equals to h, that we will need. Now we are interested to find out the area, right? What is the area? It is very simple. So area is nothing but integrate from x equals to 0 to x equals to b, and integrate, we are integrating the curve. What is the curve? Curve is y dx basically. So it is nothing but x to the power n dx. Now if we complete the integration, it will look like x to the power n plus 1 divided by n plus 1 with upper limit of b and lower limit of 0. So clearly it is b to the power n plus 1 divided by n plus 1. Now see, we still are not in a position to tell that it is 1 by n plus 1 into b into h. Here we have to apply this condition. This condition we have to apply that at x equals to b, y equals to, at x equals to b, y equals to h, and if you just put x equals to b and y equals to h, then clearly h becomes b to the power n, right? Now we just split it up. Okay, it is b to the power n into b, or b into b to the power n, whatever, and put here the values. B remains b and b to the power n becomes h, n plus 1. So this is the area we are observing here, which is the clear pattern for each and every type of shape. So this is the general pattern, this is the general formula. You can put n at any point of time and you could get your area. That is the first part. The second part is to find out the centroidal distance from the right end. Okay, now from the right end we will find or determine the centroidal distance later. First of all, we are trying to obtain the centroidal distance from the left or from the origin. Okay, that will be convenient for us. Okay, let's see. See, to find out centroid is nothing but, we have a very famous formula, not formula, this is basically a concept, that if we take moment of each slice of area, okay, each elemental area like this, okay, then it becomes, see, what is the ordinate here? This is y. From here to here it is y. If this distance is x, then clearly this ordinate is y. Then the moment becomes, what is the moment? Moment is of area. Okay, what is the area? Area is y into dx. If this small width is dx, then the area of this small element is y into dx, and if you multiply the Lieberman distance x, then it becomes x into y into dx. This is the area and this is the Lieberman distance. Now clearly we are integrating it from x equals to 0 to x equals to b. Okay, and here what we will be doing, that we will just put the entire area. What is the entire area? That we already know. The entire area is, it is nothing but x equals to 0 to x equals to b y dx. What we have already done. Okay, we will just put the value. Here what we can do, see, y equals to x to the power n, then this clearly becomes x to the power n plus 1. So if you integrate x to the power n plus 1, then it becomes x to the power n plus 2 divided by n plus 2 with a limit of b and 0. And in bottom part, in denominator, we have bh divided by n plus 1. So if you just calculate the whole thing, entire thing, let's see what happens. Then our x bar, what is x bar? X bar is the centroidal distance from the left, not the right. We want from the right. So let's first determine the centroidal distance from the left. Okay, x bar. What is x bar? Now this x bar becomes, see, b to the power n plus 2 divided by n plus 2. Here we have bh, here we have n plus 1. So b to the power n is capital H, b is there, and another b is there. Okay, so if you just cancel it out, bh from here, so you will be getting b into n plus 1 divided by n plus 2. So this is x bar. X bar is the centroidal distance from the left end only, okay, not from the right end. So finally, if you want centroidal distance from the right, just we have to subtract this value from b. Okay, so whatever centroidal distance we want for a general curve of x equals to x to the power n type, then the centroidal distance from right becomes centroidal distance from right, it becomes b minus b n plus in b into n plus 1 divided by n plus 2. It clearly n plus 2 minus n plus 1, which becomes 1. So it is nothing but 1 by n plus 2 into b. So this is the fundamental mathematics behind the area and centroid of these popular shapes, which are frequently used in many engineering aspects. So this is a very important topic which I wanted to cover. So just see the pattern. Not only just remember, but just try to get the feel what is the in general mathematics is going behind the scene. Okay. So this is for all. This is all for now. I will be trying to make more videos. Thank you.